Okay, in this video, let's talk about an interesting problem. We have a binary search tree, and we want to serialize this binary search tree into a string, then store on a disk. Later, we can pass that string through the network or print out, and later we want to use that string to reconstruct the binary search tree. How can we do that? Here is a skeleton of the solution. We already have the node and the inorder print of the tree, and this is a representation of this binary search tree. This is a printout inorder. As we can see, the inorder, this string may not be a proper representation of the binary search tree. First of all, there's many ways of reconstructing this binary search tree. For example, we use this as a root node. This is a left branch, right branch. We can build a binary search tree. If we use this node as a root node, this is a left branch, right branch, we can build another one. Or we can use this as a root node and those as a left branch. We can build a different. So there's numerous ways of building a binary search tree with this kind of a string. And how about a different representation? How about preorder? Let's take a look how the preorder do. Preorder. And here, let's move this as the beginning. Okay, as we can see, this is a inorder, preorder. Okay. The preorder is a better representation because now the root node we know at the first position, and the root node divides the rest of the array into two parts. The left branch have a smaller value, the right branch have a bigger value. And again, if we look at the left branch, we immediately find where the root node is, which is 4, right? The 4 is divides the node into left branch and right branch. The left branch is smaller, we don't have anything. The right branch is bigger, we have 5. This subarray, the same thing, we get a root node and it divides the rest of the array into left branch and right branch. So this kind of a presentation has much better chance of getting the string deserialized. Okay, so let's build this preorder. Let's do a string builder. Next, we want to say serialize. Passing the root, we give the SB. At the end, let's give a SB to string. Okay. See how we write this private static void serialize. What we're passing is node, root, and a string builder. Then we want to do the preorder traversal. Preorder. What we're passing is the root. Let's be. Then we want to modify this. we optionally passing a SB. Optionally, we need a SB. So here, instead of a printed out, we want to SB append the current root. Let's remove this line and preorder. So we don't have to call this preorder anymore, simply because we modify the signature. And let's print out this string system out print line str, and let's print it out. We will see preorder. Find now preorder 40 preorder. Oh, okay. We need to pass in the stream builder so that it's a recursive call. And you can see we truly print out the build the preorder traversal 7 left a tree and the right tree. Next, we have this string. We need to deserialize. Okay, let's write this deserialize. What we can do is we need this method. Let's get this signature private static and node deserialize. That's passing a string and str, and inside this string, first thing is we need to break it down. Str a equal str subnet with a comma. We have that, and then next thing we need to do is we need to iterate through. No, let's return like array to tree. Okay, it's passing the array, the starting index 0, end index a, length -1, and it's private static node array to tree. Here we accept a string array. Okay, string array and integer start, integer end, and we need to recursively construct that node. So first thing we do is we get an int. Int we have well equal a. So we have start, the first element, and we need to parse it integer, parse int. We have the first value, and next we need to let's write a for loop. Int I equal 0, and let's write a for loop for I equal start +1 I below equal end I plus. What we want to do is we want to search the end of the first half. So if well, let's see, well above the array, and I, let's parse it integer, parse int A. If the value is bigger than the current value, let's break, right? And we just find the index of the left half. Okay, next thing we can do is, we need to construct the node. Node root equal new node. Well, no, and we want to get the root left right equal. We need to recursively call array to tree passing A. We skip the first element because that is our root, and I -1, that's the end of our left half, and root right right equal array to tree and right half start as I, and we have the end. That way we just constructed the tree. Let's return this node. One more thing is, where should we stop? The stop is this exit condition. If start above end, this is the first stop sign, or like start below 0, or start or end above A length -1, this is the last index. In that case, we should just return now. And after that, we return the deserialize node, and we should just be fine. Let's see. A length -1, line 30. String is A. Oh, this is an array of string. Okay, as we see 4, 5, 7, 8, 9, and we print out this is this one is a little bit this is not what we expected when we deserialize the root. Then we print out the inorder. That's not the original tree we are start with. So let's check what's the problem. We first split. We get an array, and we're passing array. We get inside here start above end. Start above end. That's invalid, and invalid. Okay, invalid. We return null. Otherwise, we get the root value, and we construct the root, and we start from start +1, the start of the left, and we check the end below or equal end. If the value above the current value, that means below, right? Because you see here it's always above, here became below. Okay, so below the node value, that means we just found the boundary. We are pointing here. So next we're passing start +1. We're passing the index of this and this. We build the left half, and then we passing the index of this to this, and we build the right half. That should be fine. Let's run it again. As you can see, we just reconstructed the binary search tree, The in-order traversal is exactly as before. This is how we serialize and deserialize with preorder traversal. The postorder traversal should be similar. In that case, our root is at the lost index, and the root break down the binary search tree into two halves. And we can use a similar way of reconstruct the binary search tree with a postorder as well. Okay.